Okay, last section of the chapter 7 is on exponential growth and decay, or not the last section in the whole book, but the last chapter that our last section that we are going to cover in this class. The main point today is to be able to identify exponential growth and exponential decay. So that, of course, the essential question is, how can I tell the difference between exponential growth and decay? This is going to need for you to be able to recall the general formula for an exponential function, which is y equals a times b to the power of x. Remember, exponent is your x, which is why it's an exponential function. We learned that a was the initial value, but if you remember, b was your growth factor. Also notice that the growth factor is the variable that is attached to the exponent. And that is because as things go, if you had 100 things and it dropped by 10%, then it dropped down to 90, and then it dropped down to 81 or something like that. But either way, it would drop 10% and it would drop 10%, and that percent change happens over and over and over again, which is why that is your definition of an exponent. Remember, that tells me how many times to multiply something. So you have a standard amount or a starting amount, and that starting amount changes this amount of times. And so what you need to look at is focus on the growth amount, which is not the number outside the parentheses or anything else. You want to focus on the variable that's attached to the exponent. And what you can do is use some number sense here. The number 1, if you turn into a decimal, or turn from a decimal into a percent, means you move the decimal point 2 spots that way, add 2 zeros, and that is, of course, 100%. The number 1.23 as a percent means you move it 2 spots. It's 123%. The number 0.92, as you know, if you turn that into a percent, is 92%. And so knowing that is going to help you out when you look at it, because if the growth number that you're looking at is bigger than 1, which again represents 100%, then it means the function is growing. If the change in the amount is smaller than 1, or 100%, then it means it is decaying. Again, 100% means everything you have. So if it's more than that, that means you're earning, or that is growing. And if it's less than 100%, that means it's decaying. That's really all you're looking at. So looking at these examples real quick before we move to one more type of problem. It's just going to say describe each equation as exponential growth, exponential decay, or neither. And you just have to first off make sure it's exponential. Notice that the x is in the exponent, which is good. Now we focus on the growth factor, which is this number here. We see that it's smaller than 1, and so this would be decay. And that's all you're going to be asked to do. Looking at the next one here, again, we see that it's exponential because the x is in the exponent, and so we focus on the growth factor, which is bigger than 1, obviously, and so this is growth. Again, it does not matter, even though this number is a big number, it doesn't matter what this number is, because this is what determines growth or decay. So you have a big number here but a small number there, but that's why it's decay. You have a small number here but a number bigger than 1 here. Again, this determines everything. We don't care about the number outside, we care about the number attached to the variable. Now C is tricky because you notice that this variable is not in the exponent. This is actually neither, because this is 1.42 times x, which of course means that that's like a mx plus b. This is actually linear if you're trying to keep track of that. D gets into the other type of decay and growth that you need to look for, which is a fraction. And the key thing about the fraction is we know how to turn a fraction into a decimal. So what you want to do, and I would write this in your notes, is to convert 5/3. And so you simply take 5/3 and do 5 divided by 3, which is 1.67, which of course means that this is growth because that is bigger than 1. On E, looking at that number, you do 45 divided by 46, which is 0.98, which means that it is decay. Now, you can use common sense on fractions, keeping in mind that this represents the number of pieces that represent a whole. In other words, you have something cut up into thirds, and you have 5/3. Obviously, 3/3 represents 1, and so since this number is bigger than that number, it's going to be growth because it's going to be higher than 1. Whereas in this one, If the number is smaller than the number of slices that's there or number of parts that's there, then it's going to be smaller than 1, because again, 1 in this case would be 46 over 46. It's smaller than 46, which means, of course, that it's decay. But again, however you learn that, just make sure you're able to identify growth and decay, because that will help you out later on down the line. The last type is an application problem that deals with invested money and what we call compound interest. And it just looks like this. Again, we're just going to work this out and talk about it. You've actually seen this question in 7.6, but it's just a different formula that's there. The amount of money accrued at the end of n years when a certain amount P is invested at a rate R is given by the formula A equals P parentheses 1 plus R to the power of n. If the interest is compounded annually, if a person invests $3.19 in the account that pays 8% interest, compounded annually, find a balance after 13 years. And so what we're being asked to do here is to simply take a formula, because remember I told you at one point, if there's a lot of words in a problem, it means it's probably easy to do. And so what we'll do is we will first off write the formula and make sure we know what everything is. Again, the good news about this formula, even though this will have to be memorized at some point for you, I don't know if it's so much right now, because a lot of questions I see actually give you this formula. This is just the general format, because P is the principal, or the amount that you're putting in, so this is your starting point. 1, of course, represents your 100%, so that's your 100%. If it's increasing by R 8%, you're going to have 100% plus 8%, which is going to be your growth factor, and then this is the number of times that it goes over. So again, this is pretty much the same as your Y is equal to A times B to the X. It's just that we have to actually identify B. And so let's plug these things in. Again, P represents the amount that you're starting with, which is $3.19. 1 plus, we need our rate, which is 8%. Keep in mind, 8% means you move the decimal from here 2 spots forward, and so that is 0.08. And then N represents the number of years, which is 13, and all you have to do from there is type that in. So 319 parentheses 1 plus 0.08 to the 13th is 867.56. Now I'm not sure. I think I'm asking you to round to the nearest dollar. Rounding to the nearest dollar in this question means you're stopping at no change, so you want to turn this into 868 and leave it at that. Alright. On your computers today, you are actually going to have to type this whole part in, where it's going to be A equals, and then type in what you're going to actually use. That way I know you absolutely know what you're typing in. Also be careful, because if you see something that is something like 3.7%, you've got to remember that 3.7% converted is 0.037, and so you actually have 3 digits after the decimal instead of 2. So just keep that in mind. Bottom line on this, again, especially in my class, I know we're trying to fight to keep ourselves in a good position. We did not all start the second semester so well, and it'll help you to kind of make sure you fight as hard as you can. So start preparing for the test now. Again, you've got a week to take this test. You've got all weekend to study some notes. You've got all weekend to look over some things, get some practice. And again, the reason is because this is a kind chapter compared to what's coming up soon. So make sure you use this chapter as some insurance, and what that'll do for you is give you room to breathe in case the material catches you off guard. So go ahead and go to your homework, and again, use the time you have to ask questions, work together, and do what's necessary to get better at it. Keep in mind, math is a skill-based topic, and you only get better at a skill by practicing it, not just by watching, reading it, or talking about it. So get out there and get some practice. Good luck.